3.
All right, guys, today we're going to talk about key terms for chemical reactions. And some of those key terms are, well, first of all, a chemical reaction is when two elements or compounds are combined to make a new substance. So it's very important that you understand that a new substance is being made. So the things that are being combined are called the reactants, and that's everything to the left of the arrow. The arrow stands for yields or produces, and everything to the right of the arrow is called the products. So those are key terms. You have reactants to the left of the arrow, and those are the substances getting combined. You have the products, those are things to the right of the arrow, those are getting produced. The arrow stands for yields or produces, and then you're going to see that there's these little things like S, G, A, Q, and L, and those are called phase symbols. And phase symbols tell the state of matter that substance is in during the reaction. So if a phase symbol is an S, it's a solid. If it's a G, it's a gas. If it's an L, it's a liquid. If it's AQ, and you'll see that a lot, that is a solid dissolved in water. It's called an aqueous solution. An aqueous solution, and you always see that on the STAR test and everything like that. So you definitely want to know that AQ. Now, some other key terms that we need to make sure that we understand is the number that stands right here, that stands for the amount of atoms of that element, is called the subscript. And the subscript stands for the amount of atoms of that element. If there's a 1, you don't have to write it, and it's understood. And then the charge is called the superscript. And the superscript stands for the charge of the atom, which is also called the oxidation number. And we saw that when we were doing nomenclature. And that's going to be important later because the total charge of a compound has to be 0. And if you remember our crisscross method, we had a +2 would go here, the 1 would go here. Sorry, that's minus. So oxygen's always a -2, hydrogen's a +1. So you crisscross the numbers, and that gives you the lowest common denominator to cancel out because the total charge of a compound must be 0. So if you look over here, when you're reviewing making compounds, the total charge has to be 0. Okay, so the total charge must cancel out. So if I have magnesium here, and I've got plus phosphorus in my reactants, and then I'm producing magnesium phosphide, okay, magnesium's a +2, phosphorus is a -3, so if I crisscross and reduce, I get Mg3P2, and that is magnesium phosphide, okay, and that is my product. Right? Now, another thing that you're going to see a lot of when we do chemical reactions are called diatomic elements. And the diatomic elements are elements that cannot stand alone. They have to have 2 if they're not combined with something. The list for diatomic elements is hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And how I remember that is H, no, halogens. So H, no, halogens, because that's the list of all the diatomic elements. H, no, halogens. All right? And so like when they're combining with something, they can have 1. So if you have HCl, that's combined with something, so you can have 1 of each because that's a +1 and a -1. But you can't just write H plus Cl. It would have to be H2 plus Cl2 because it's diatomic. All right, so those are some key terms that you're going to see in chemical reactions.